All right, so Will is on the line now for you guys.
Awesome. Thank
you
so
again.
much.
Thank you.
Hi, everybody. My name is Will Hara. I'm the Technical Manager for the United States for Sanremo. I'm just going to take you guys on a brief tour of our equipment and the differences between the different models that we have. So we had this. We were going to do this all via video, but unfortunately, we're having some network issues with our Wi-Fi that we've been fighting with all morning. So I'm going to do my best to narrate this to help paint a picture for you guys, and then, like Alessio said, we're going to try to set something up in the future visually to help take you guys through the machines. So just to touch on a couple of things that Alessio had mentioned already, all our machines are hand-built in Italy, in Treviso, Italy, which is on the eastern coast of Italy. It's a very industrious area, and all our components are made in Italy. So we do not fabricate our boilers and chassis and things in-house, but we use local craftsmen to make sure that whoever's building the boiler, whoever's building the chassis, whoever's developing the board for us, that they're all experts in their field and that they're providing us with the highest quality of component and et cetera. So now we have a couple different models. So our entry-level model, or our restaurant-grade model, is our Zoe. This is something that you would use in a restaurant, in a super low-volume cafe. It is a traditional heat exchange machine, where it is a single boiler setup. So you don't have a ton of control over temperature. It uses a pressure stack, like other traditional entry-level machines at this range. It does have, all our machines are auto-volumetric, so we do not offer a semi-automatic version. Everything has a programmable volumetric, so we have flow meters in all our machines. The Zoe is also equipped with LED shot timers, which is a cool feature for something in this range. Not a lot of machines in this range offer that. So then we offer that in 2 and 3 groups. We typically stock the 2-group Zoe competitions in black or white. If you're interested in a 3-group, we would have to special order it from Italy. Lead time is usually around 4 to 6 weeks. Moving away from that, that's the only machine that we have in that segment as far as traditional. We have other machines available worldwide, but in the interest of keeping costs down for UL, the Zoe is the only traditional heat exchange machine that we offer. So moving away from that, we have 3 different machines in our specialty segment. Our newest machine is actually our entry-level to the specialty segment, which is our F18. It's like an evolution of the Zoe, where we retain a copper boiler internally for the steam. We use a heat exchange system to preheat our water before it enters into a stainless steel coffee boiler, where we do our final heating. So even though we do use a heat exchange system for preheat, with the coffee boiler setup and our dry heating element in the brew group, we're able to hold a very, very stable temperature through the brew extraction, which is pretty nice. So other features for this machine, it has cool touch steam wands. Like I said, all our machines have volumetrics. It has a touch screen for very, very easy programming. You can set pre-infusion, your volume dosage. Each group can be set individually for a temperature, so it's a multi-boiler machine. And then that's pretty much it. It's a very simple machine. And then moving on from that, we have the Cafe
hey,
Racer.
Will, yeah. Can we see if anybody has any questions before we move on to the Cafe Racer?
Of course.
Does anybody?
So on the pre-infusion, is it a traditional time on, time off type pre-infusion, or is it actually more of a restrictive pre-infusion?
Okay, so on the Zoe, it's a time on, time off, where we use the same brew valve to pulse the coffee puck. On all our specialty machines, on the F18 and on the Cafe Racer, we use an independent pre-infusion channel that has its own flow restrictor. So it has its own solenoid, its own flow path, and its own flow restrictor. So if you're using pre-infusion on one group and you're in your main extraction phase on another group, they won't interfere with each other.
Gotcha.
So on as far as pre-infusion setting goes, we cannot change the flow because it's dictated by a flow restrictor, but you can pre-infuse up to 25 seconds. So you can change the amount of time that you can pre-infuse, but you can't change the flow.
And what is that restrictive flow rate?
It's about roughly
or that
25.
or the orifice itself?
So the orifice itself is smaller than 0.2 millimeter. It's a very, very small orifice. The actual flow time, just give me 1 second, let me just pull it up for you. Okay. All right, so flow is about 25 to 30 milliliters per 10 seconds at 9 bar. So it's a very soft pre-infusion.
Anybody else have any questions on the F18 or the Zoe? I know we're going fast, but.
I guess my only other question is in the brew group itself, because I know you guys are using like a E61 brew group?
Correct. So on the F18, we're using our version of the E61 that we've dubbed the SR61. Not a super creative name, but on the outside, it looks like a standard E61. So typically on an E61 group, you have 2 ports on the back. So that usually you'll use that for a thermal siphon effect. On our groups, we have a single port on the back. So we're not using thermal siphon. We're just injecting it with the heated water from the coffee boiler. So behind the brew group, you have a half a liter stainless steel coffee boiler, which receives the preheated water. As I mentioned earlier, it gets preheated through the heat exchanger, goes into this coffee boiler, and wherever the group is set to, let's say you have it set to 200 degrees, it'll heat that water up to 200 degrees. And then from there, it'll pass into the group, which also has a dry heating element to help keep with stability, and then into a solenoid valve, and then into your coffee. So it does look like an E61 group from the outside, where it does have the same solenoid placement on the bottom, but on the back there's just a single port that allows that heated water to come in, pass through a chute, through the inside, and into the solenoid. And
does it have an infusion chamber in the brew group, or is it just straight channels?
It's kind of like an infusion chamber. It's not like it is on the standard E61 where it flows in and then it goes into through the chamber. It does fill internally before passing through a flow path into the. So it does fill and then it goes through a flow restrictor and then into the solenoid. So it's not a massive chamber as you would find on a standard E61 group, but you do have a cycle of water that's happening before it hits the solenoid valve.
Yeah, I'm talking more post brew valve solenoid.
No, it does not. It's just a solenoid valve, and then from there it goes through the dispersion screw.
Gotcha.
Does anybody else have a question regarding the Zoe?
Good question, by the way.
Okay, well, I think we're ready to move on to the, I believe, the Cafe Racer.
Okay, so now we're going to have some similarities between the Racer and the Opera, mainly in how we're doing our final heating. So now everything on the Racer and on the Opera consists of stainless steel. So we use a 615L stainless, which is one of the higher grades that are food safe for stainless steel. The reason why we use this grade is it has a higher resistance to corrosion, and it also helps us with our temperature stability. Now the steam boiler, the coffee boiler, and the groups are all stainless steel. Also our portafilters are stainless steel on the Racer and Opera. On the F18, our brew group is made of brass and it's nickel plated like a standard E61 group, and our portafilters are also brass as well that are also nickel plated. So on the Racer and Opera, everything is made of stainless steel. Now, on the Cafe Racer, it's a step up from the F18. We are no longer using a heat exchange system to preheat. So now the same coffee boilers that we're using in the F18 are now our preheat boilers in the Cafe Racer. So what we do is the water enters these boilers. We'll heat the water to around 180, 185 degrees. And from there, it'll enter the brew group, which is also a boiler. So our groups are about a half a liter, and the water is being heated at that point right before it's being dispersed into the coffee. So on the brew group, we have the main group, which is, like I said, our half-liter boiler, and underneath that, we have a dry heating element above the portafilter. So as you see, we like to keep multiple points of heating through the entire extraction process. So our goal is to try and keep that temperature as stable as possible whether you're pulling 1, 2, 3, 4 shots, or if you're in a heavy rush. So all our heating elements, so now this is talking about our specialty range. In the Zoe, like I said, it's a very traditional setup, uses a pressure stat, very economical components. It's nothing fancy, it's just very reliable, and it's built to endure that restaurant environment. On our specialty grade machines, we keep that same craftsmanship ideology, but we want to do things as efficiently as possible. So anything that has a heating element is PID controlled. So everything is computer algorithm controlled, whether it's a portafilter ring, a dry heating element, a wet boiler, everything is integrated into each other using PID. So we do this obviously for temperature stability, and we also do this to use as little energy as possible to operate the machine. So if you compare our equipment versus other competitor machines, you'll notice that we tend to use less energy in total for consumption. So the machines will do, another example, on our heating elements, so for the steam boiler, you'll notice that we run 3 independent legs to the steam boiler element. The reason why we do this is we control each leg through the computer. So we can actually increase or decrease the wattage draw of the machine within programming. So let's say, so on a 2-group racer, we have the ability to crank it up to almost 40 amps, or we can run it at about 25 amps. And this can all be controlled within programming. So back in the day, if you're a field tech, if you have a customer that keeps blowing the circuit breaker and you have the ability to kind of disable one of the legs, you would kind of just unhook it and electrical tape it, and then they would be able to run at a lower amperage. We can actually do this properly within programming, which is a cool feature. So going back to the racer, we can control our amperage draw within programming. So like I said, anything that has a heating element is PID controlled. And the name of the game is to try and keep things as stable as possible using these complex algorithms within the computer. So the water path, right? Water comes in cold, it gets preheated, and then it goes into the main coffee boiler / group where it does its final heating, and then it's extracted. So just like the F18, it does have its own independent pre-infusion solenoid, flow path, and flow restrictor. The flow restrictor size is the same as the F18, and it has the same flow of 25 to 30 milliliters per 30 seconds. So again, a soft pre-infusion. You can't change that pre-infusion flow, but you can change the amount of time that you can operate that pre-infusion. So any questions on that?
Yeah, so just back to that pre-infusion. So in the programming of it, you're basically programming the length of time that you're going to have that solenoid restricted, and then when you turn it off, it's just going to full flow, correct? Or can you program in a delay?
Okay, so on this one, so we don't have a delay function because we're using 2 individual solenoids. So for pre-infusion, it has its own solenoid versus the brew solenoid that's handling the dispersion of the water. So you can change the amount of time that it is operating, but we don't have a delay time in between.
Okay, that's cool. Well, I mean, I wouldn't see why we would want a delay, but I always have to ask because there's that gray area of, you don't know what the machine can or cannot do.
No, of course, it's a good question because typically, for example, like if you're using a competitor machine that uses, they call it pre-wet, where they're using the same solenoid valve to pre-wet the puck, they usually have a delay time in between. So it's usually like pre-wet for 5 seconds, and there's like a 1 second or 2 second delay, and then it goes into its main extraction. So we don't offer that because the pre-infusion is happening independently. So we didn't see a need to offer that dwell time in between the pre-infusion and the main extraction, if that makes sense.
Yes.
Good question, though.
Hey, Will, this is Alan from Houston calling.
Hey, Alan.
Hey, man, what's the mechanism by which you control the amperage going to the heating element?
So the way that we do that is if you look at our heating, so what I can do is I can email some photos and stuff to Ruth that she can distribute. So if you look at our heating elements, we have the common leg that gets distributed through 3 different prongs. and then you have one individual leg. So are you familiar with three-phase machines?
I am, yeah.
Okay, so typically on a three-phase machine, you have an individual leg per heating circuit on the heating element. So you have one leg, and then it loops around to the common, another leg loops around to the common, and another leg, and it loops around to the common. So we utilize that same style of heating element that on each leg is controlled by its own solid-state relay. So what we can do is we can shut off one of those legs within programming. So let's say we go into programming, we tell the machine we want it to operate at 5,500 watts. It'll turn off one of those legs when it's doing its full heat.
Cool. Thanks, Matt.
No problem. Any other questions?
You were muted, Ruth.
Yeah, I know. Will got it.
Cool. Also one thing to note on our specialty machines, on our flow meters, we use a 4-magnet impeller. The reason why we do that is so we have a higher resolution of feedback to the board. So the board is able to calculate a higher rate of flow to try and give you as much volumetric stability as possible in between your shots. Typically on a flow meter, you'll find. I'm sorry?
Is that the same on the F-18?
Yes, F-18, Racer, and Opera.
Okay. But the Zoe is a traditional two magnet?
Correct.
Hey, Will, it's Chuck.
Hey. What's
Hey,
up?
man. Are you able to share with these guys the Sanremo USA YouTube channel where you're putting up really amazing videos?
So those videos were actually made in Italy by our Italian marketing team. So I actually have never accessed them, to be honest with you. I'm actually pulling it up now on my phone for the first time.
Yeah, but the ones that you made a couple of, you and Alessio made a couple.
Yeah, I've thrown up a couple of videos on our Instagram if you want to take a look at that. So, so during the whole COVID situation, when things were really slow, I started doing something called Tech Tuesday, where I made a couple of videos displaying some of our features and the technology inside our machines. So if you jump on our Instagram page, which is Sanremo Coffee Machines USA, you can see a couple of those videos. Good point, Chuck. Sorry about that.
All good.
So we're out of time. Will, do you want to kind of wrap it up, or did you get everything out? I don't think you got to the opera quite.
Didn't get to the opera yet.
Yeah.
Yeah. So to summarize the opera really quickly, so the opera offers similar heating points as the Racer. Just instead of using a small coffee boiler to preheat the water, we're using a larger universal preheat boiler within the machine. So water's preheated in one boiler, and then it's distributed to the groups where the final heating happens in the same style as the Racer, where it has a brew group / boiler. The main difference with the Opera is that it's equipped with gear pumps, which allows us to do pressure profiling. So we can program our pre-infusion pressure, our main extraction pressure, and our post-infusion pressure and time via an app or via Wi-Fi. And that's the main difference with the Opera. It's a very technical machine. And so as a technician, so it's our first specialty machine that we've released, and it's not unfortunately as user-friendly as the F-18 and the Racer and the Zoe are, but we could definitely spend a whole day going over the Opera. But main difference between that, so like I said, it has gear pumps, it does pressure profiling. The Racer does not do pressure profiling, it just has that pre-infusion jiggler, so that allows you to do a flow-based pre-infusion. And that's pretty much it in terms of differences between the Opera and the Racer. So
on the pump, is it just a 3 phases of pressure adjustment, or can you actually be ramping and up and down throughout the whole cycle?
So the ramping is dictated through a recipe that you put on. So you can't change it on the fly. So within programming, you can tell the group so you have 6 different programs per group. and you can set those programs individually and tell it you want it to do pre-infusion at 5 bar for 8 seconds. You can tell it you want the main extraction to be at 10 bar for 80 milliliters, and then you can tell it to post-infuse at 3 bar for the remaining 20 milliliters of that shot. So based on the input that you give it for that recipe is how it will pressure profile.
Okay, so it's based on time, then milliliter.
Correct. So the pre-infusion is time-based. The main extraction is either volumetric or gravimetric if you're using our Bluetooth scales. So it'll either look for a target of, let's say you input 80 milliliters or you input 40 grams. It'll look for that target. And the way a pre-infusion, post-infusion works is you'll tell it at the last X amount of milliliters. Let's say you put in the last 10 milliliters, the machine will automatically calculate those last 10 milliliters and then change the pressure based on your input.